To understand how a solar panel works, you need to understand three basic concepts. Concept number one, solar cells. A solar power system or array is a group of modules or panels which in itself is composed of a group of solar cells. The energy production happens at the cell level, and everything else is just an interconnection that allows for greater power output. So the key thing to understand is how a cell produces electricity. Concept number two, outer shell electrons. The majority of currently produced solar cells are made out of silicon. Silicon's group or column in the periodic table all have 4 electrons on its outer shell. Let's go through what that means. This is a silicon atom. Each atom has the same number of protons, which are positive charges, and electrons, which are negative charges. The 4 outer electrons are crucial because they either bond with other atoms or they flow freely. If you put a bunch of silicon atoms together, they will form a grid. This happens because each silicon atom wants to have 8 electrons in its outer shell. This is referred to in chemistry as the octet rule. By each sharing their 4 outer electrons with each other, each silicon atom manages to have 8 outer electrons. Now, these bonded electrons forming the silicon grid are not considered free and can therefore not participate in current flow. Concept number 3, creating 2 types of silicon so that we can actually use the sun's light. Let's take our silicon grid and divide it into 2 layers. In the first layer, we introduce some phosphorus atoms. Phosphorus's group contains 5 electrons in its outer shell. In this layer, per phosphorus atom, we now have 1 extra electron that can't really bond to any of its silicon neighbors. The surrounding silicon atoms already have 8 electrons around them and have reached a stable state. Since an electron is a negatively charged particle and we have these lonely unbonded electrons, we can refer to this layer as the N-type, negative type layer. In our second silicon layer, we want to add some boron atoms. Boron is in group 3, meaning it has 3 outer electrons, 1 less than silicon. This means that per introduced boron atom in our grid, we now have a missing electron to share in this area. We can call this missing electron an electron hole. Now, since an electron is a negatively charged particle, we could refer to the holes as positively charged particles. For ease of understanding and imagination, if we refer to the first layer with the extra electron as the N-type layer, let's refer to the second layer with a missing electron with an electron hole as the P-type, positive type layer. If we now put these 2 layers on top of each other, the extra electrons from the N-type layer are attracted to the holes in the P-type layer, and vice versa. Excess electrons from the N-type diffuse towards the P-type, and excess holes from the P-type diffuse towards the N-type. Instinctively, you'd think that all of our holes and all of our electrons would diffuse across these 2 layers. This is, however, not a gas. Electrons are negatively charged particles. When the diffusion begins happening, electrons that leave the N-type layer make that layer less negative, so more positive. This is because every atom has the same number of negative electrons and positive protons. If some of the electrons of the outer shell leave or diffuse, the rest of the atom is still attached to that silicon grid. So, as a result of joining these 2 layers, the N-type layer has become slightly more positive because of some of the diffusion. The P-type layer's holes also diffuse, and a diminishing of these positive particles makes the area slightly more negative. In between, we have a neutral area, also referred to as a depletion region. In this region, the previously described diffusion took place. And now that we understand all of this, finally, light comes in. When a light photon, which is like an energy packet, hits our solar cell with enough energy to reach the depletion region, an electron and a hole get separated. Light with wavelengths between 400 and 1100 nanometers have enough energy to do this. This electron and hole get separated. When an electron-hole pair gets separated, the electron flows to the n-type layer. It is attracted to it now because it is slightly positive. The hole, the positive particle, now flows to the p-type layer because it is slightly more negative. They flow in those directions because opposite charges are attracted to each other. If I now add a metal conductor at the top and at the bottom of my layers, the top as small as possible so that light can still get through, I now provide a path for the electron to flow through a circuit and recombine with the hole again. As the electron flows through the wire, it can carry out work for us and light a light bulb, for example. And that's how it all works. I can now join multiple solar cells together and create a solar panel or a solar module, and join multiple modules together and create a solar system. Thanks for watching. If you like that, you'll probably like this video as well.